So like for generally I use this CF tool for yeah, so I use the CF tool for submitting my solutions during contests. It makes it a lot more simpler. So for example, if you consider this problem, I can just go to its directory and I can just run it here and it will automatically test it against the sample cases I download beforehand. And I can also say submit it directly from command line, so it makes working with stuff a lot faster. Obviously, I get wrong answer here because it's an empty file. So and yeah, using that makes the workflow rather faster. So for example, this contest is 1551. I can have to change the configuration. Yeah. So I can use this contest ID, and when the countdown is over, it will automatically say create a folder with all the test cases downloaded and my template copied and generated here. Yeah, so I generally just open the complete problem set and I generally read the input before actually reading the rest of the problem. So for example, here I just write the code for taking the test cases. And I generally have like an external function that I make for printing the answer. And you have to print two integers. Okay. So okay, so C1 plus 2C2 should be equal to n and the difference should be minimum. So ideally you would like to split it around 1 by 3. So what you can, so ideally here you like to split it about 1 by 3. So I just set C is equal to 1 by 3, C1 and C2 is equal to n minus C1. C2 is equal to n by 3 and this to be n minus 2 into C2. And there's a bit of wiggle space that you have. So it might be n floor or it might be ceiling. So I just pick the one with the least difference in some minus 1 b is equal to minus 1. Diff is equal to some large number. And if abs C1 minus C2 is greater than diff, A is equal to C1, B is equal to C2, and I just output A and B. I see. Right, sorry, less. And then I set the diff to be this difference. Diff is equal to ab C1 minus C2. Yeah, that matches the answers. So I'll just submit this. Okay, for next problem, P1 simplified function of P2. So again, I'll first look at the input. Int and have to output a single integer. It's a single string. And what's the difference between the first and second problem? See problem 2 before start. Okay. You see, so the input format is different as well. All right. We have a previous string as yes, you want to introduce a piece of chalk of two colors, red and green. Is wonderful if the following conditions are met. One color or it is in painting. Same color. Each two letters. Okay. The number of letters painted is equal to the number of letters painted. Each letter of the string is exactly one color, red or green, or not painted. Two letters which are painted the same color are different. Okay. So you have at most 26 letters for the same color. The number of letters painted in red is equal to number of letters painted in green. Okay. Yeah, so you just pick, say, 20, you find the frequency of elements to be 26, the alphabet size. For seeing this. And the answer is restricted to, say, a size of 26. And the string is, the answer can also be 0 if it's like a one letter long string. So to check if now to color a string with this character, I'd ideally like to color the first alphabet whatever I can. And if A is greater than K and B is greater than K, I return K to be the answer. And since I made changes to it, I list this. It gives a right. I should try with the worst case and then go down. And if none of these is it's not like good. And if none of them work, the answer has to be 0. So I just test this. It's taking rather long for some reason. It really shouldn't take this long. If C equals to 0, F is equal to G. Tab. Right. 1 3 output. Okay. Hmm. 0 C. What size is this? Never put number of characters painted green. Mhm. We don't actually use. See. So assign one. Okay, right. If A is less than B, I try to fill it first. One. If A is less than or equal to B, then in one. This also doesn't work. B1, then 1. So if I have code forces, C, C, O, A instead, cool. Yeah, so if a character occurs more than twice, you can just paint one of them to green, the other one red, and if a character occurs only one, you can, assign it green, and then further, if some other character which occurs one, you can pair it up and assign that to be green, assign the other that one to be red. Each element of the sequence has the pattern one of the key color. Okay, so increase the colors. Cool. Each element of sequence either painted in one of the key colors or it isn't painted. It's painted in the same color. I'll calculate numbers for equal. The total number of painted elements is the maximum among all. I see. And there's key colors. Again, only the frequency should matter. And if you have, say, all right, and AM for auto X, and X. Plus X. You like to do a similar thing. I was greedily assigning the characters to stuff. So what I can do is make a vector of vector. AI dot pushback AI. Now I go through all the options I have. X and V of X. If the number of element is greater than k, it's optimal to assign at least one to everything. I is equal to k. C I dot push back V I. You continue, and if there's less than k elements, it's better to assign it to all the elements which have less. Okay. X for I in V. C P dot push back I. P is equal to P plus 1 mod k. And then I find the min size over everything. If I is k, U N M N S C C I. And then I resize Ci to only contain k elements. Mn elements. The answer array initially 0. Just print the answer here first. C out n to J and Ci. Answer J is equal to I plus 1. So each character occurs thrice. Okay, here also the character occurs twice. Thrice, once. Okay. Yeah, this looks fine. Okay, so here what I did was just, if a character occurs greater than k times, you can just place it, you can, color, you can pick k of them and just color them distinct colors. And if it occurs less than k times, you greedily assign it to all the values to all the arrays to all the colors you can, which till now have the minimum number of colors assigned to it. Why print the maximum number of footprints if there's no way to make a new? Stephen Quinn wants to write a story, so very okay. Composes Stephen writes out n words consisting of the first five. The maximum number of words. Okay, and what makes an interesting story? If there occurs a letter which occurs among all words. The story is interesting if there exists a letter which occurs among all words of story more than all the letters together. Okay, so it must occur more than n by 2 times. Given a sequence, your task is choose a maximum number of them to make an interesting story. Okay. It contains a word. I see. So first thing we can do is, since there are only 5 characters, you can just fix the character which occurs the maximum number of times. So the following each contains a word. Cool. I'll just store the strings. Okay. I see. B C A A A D A. So ideally, I'd like to. The first thing I'd want to do is just pick characters which have. So after fixing the character, I'd like to just pick the strings which have like the maximum occurrences of the character. But that might not work necessarily. Let's see, is equals C is less than 5. What else can I do? B A C A D. B A C A D A B A A B C D E. More than all. Get the n by 2 times. See. So I can reduce it to have say a bunch of pair of numbers A and B. I need to pick pairs such that sum of A is greater than sum of B. First thing I'll do is just pick. Okay, right. So I can view each. I'll just make another array fngn, and I can view each string as either if it is that character, sorry, for all the characters in the string, if it is that character, I increment fi, else I increment gi. Okay, now first of all I pick all the strings where fi is greater than gi. I'll order the strings such that the difference is as large, so that the larger difference comes first. Here this good, the current difference. So if for the first string the difference is less than or equal to 0, this will not work. Sorry. I just need to store the difference actually. This difference less than or equal to 0, I can't do anything. Let's say the difference is, and that also makes a life easier, as I can just sort f in decreasing order. Now if f0 is less than or equal to 0, whatever I do, this string can't be made, the sum can't be positive. So I now have to pick the longest prefix whose sum is positive. So if fi is greater than 0, if cur is greater than 0, increment k Yikes. Did I do something weird? X. Okay, X S I. Cool. N1 CF test here some D1. So for the previous one, I fixed the maximum number of characters before. So say I fix the character which occurs the maximum number of times, and then for each string, it's you can view it like you can consider the number of occurrences the character I picked occur and subtract it from, and from it subtract the occurrences of all the other strings. Sorry, occurrence of other characters in that string. And from here, if so, now you get, rather than working with strings, you just have to pick a number, and you have to pick some number such that their sum is greater than 0. So what you do is just sort these numbers and pick the longest prefix you can such that the sum remains 0. You sort them in decreasing order. And for this domino problem, again, nmk is less than cn of nmk, and I have to output yes if I can, or else I have to put output no. Yes, no, and this is a boolean. And okay, I don't have to construct the answer in this case, just have to print yes or no. The dominant figure consists of two cells having common side. It may be horizontal. Okay, be horizontal, and it may be vertical. And to figure out whether it's placed first, so that exactly key of them are horizontal and all the other dominoes are vertical. So whenever you, okay, so a thing about dominoes is whenever you place them on, say, a grid, And if you say color the grid in chessboard pattern, it always covers one white cell and one black cell, and that is an usual, and that's an observation that comes out handy a lot, because so you can just divide the grid so you can in a sense look at two separate parts, the two grids you get in a separately, and a domino say like an edge between these two black grids and white grids, which allows you to like think of the this grid in terms of a graph. So we need to figure out if it is possible to place exactly an nm by 2 dominoes. I see. So I join a cell to its neighbor and need to pick exactly, need to check if I can pick. So basically I have a bipartite graph and I need to check if I can pick exactly k edges of one type. Hmm. Hmm. I see. For D1 and D2. Let's just play around with the values first. With the 4 by 4 grid, 1, 2, 3, 4. I need to have exactly two horizontal and rest to be vertical. Horizontal, horizontal, vertical. I mean, 2 is pretty easy. You can just take a square. 2 cross 3. Okay, all vertical is pretty easy to see. 3, 2, 3. Okay. So see if you have an even number of edges, if the k is even, can't I just yeah, if k is even I can easily do a construction. Just place them next to each other, and for the rest you should be able to. No, if k has the same parity as n. No, not even that. Interesting. Hmm. So at least one of the two characters, say at least n or m, have to be even, right? Because nm is even. Okay, so I'll just assume m is even. Hmm. Okay. if now I'd greedy like to place the k dominoes on the first row, then I'd like to place them in the first column, so on. And okay, cool. And yeah, when you swap it, the vertical character becomes the horizontal one. Okay, so n is even. I see. It's a bit confusing. I'll just make a 3 by 2 grid. 2 by 3. Dominoes like this. Right. You're left with some characters. Okay. See, if n cleanly divides k, you're basically done. If n does not cleanly divide k, you have some stuff left over. This leftover stuff causes an issue if it's odd. So if k is odd, okay, so if k is even, you're k is even, you're done. K is even, yes, an answer exists. If k instead is odd, it was horizontal, right? Yeah, it was horizontal. First, second, carry. Okay, I'd like to split it in 2 portions. I see. If n is odd, right? For example, case even the answer is 0. If n is odd, this is something. No, right. If k is odd, then answer is 0. If k k if n is odd and k covers greater than half the grid. Hmm. Let's have a look. Sorry. As you can. Guess I should. What now? 0, 1. Okay, should be fine. Where did this come from? Yes, yes, no, yes. Lot of cases here. Yeah, so this was just parity checking. If you have, say, if you need an odd number, I think I'll just explain it later at the end. There's a lot of cases and it's hard to verbalize them simply. And now I need a construction as well. This is pretty easy. Shouldn't be too hard. Solve. What solve? Just copy this function over. All right. Return cout. No. 0. Wait. It's a bit annoying. In terminal side में horizontal vertically we need to so that exactly here the horizontal NM is even. You can train at lower the lower to say how come the mark was in the room. That's an annoying format. It would have been easier just to number them differently, but okay. Cool. And I'll just add a flipped tag. It is equal to 0. Because if you have a construction, I'll have to flip it back later when outputting. All right. Vector string G N string. I'll see how to deal with. I'll just give each DOM one unique number for now. I'll see how to deal with the output later. Now I'll keep placing dominoes at each position. For int I is less than n. First, please find one. Back to the construction. Honestly, it's a bit annoying. It might be a good idea to skip this one for now. Consider a sequence of integers e1, e2, e3. You can select any element of sequence, delete after element is shifted to right by one position, so there are no empty spaces in the sequence. Consider you can select any element of sequence and delete it after an element is deleted. All the elements to the right are shifted left by one position, so there are no empty spaces in the sequence. After any of the sequence length decreases by 1. Okay, the indices of the element after the move are recalculated. Alright. We're given a sequence and number key, you need to find the minimum you have to make so that the resulting string these k elements are equal to. Alright, and A only contains character between. I mean, if no one exists, you can't do anything. And then the 2 should occur after 1. Is that it? I think that's it. Int n k c n k, and you can just delete characters. That's the best you can do. Oh, this is pretty easy, I guess. Int x is equal to 1 for int I is equal to 0 is system. Right. If 1 doesn't exist, the answer can still be true. Okay. So at least k indices satisfy bi is equal to I. Cool. So if a character occurs before its position, you can never move it to the right place. So it will never contribute to the answer. Looks like a DP. Just do this. If AI is less than I plus 1, AI is equal to 0. Because it will never contribute to the answer. Now if this this is equal to R0. Once it doesn't exist, I'll just return -1. Okay, good. Are there cases here? I can't. Yeah, so yeah, that's fine. A is less than I plus 1. So this should be greater. So n, okay, fine, this is okay. So 1 1 2 3 5 6. 1 1 2 3 4 5 6. You just remove one character. K n square n square. Like AI minus I to 0 for as many characters as I can. If I delete some character, okay, at least K. Right, I just need the target of K. If you look at the array AI minus I, what a single step does is in decrease a suffix. Yeah, what a single step does is decrease the suffix value and remove one of the characters. Sorry, increase the suffix AI minus I. 1 1 2 3 4 5 6. This 0 1 2 0 1 1 1 1 1. It decreases suffix 3 minus 2 here. Alternatively, it's N and K. Can I build a TP here? TPIK to be the minimum number of erases. to get Turkey. See, for indirect is less than that work. That won't work. Yeah, that won't work. TPI ij equal to number of yeah, I consider one. Alright. Minus one. 1, 2. 1, 1. If we remove this one, this turn into 1. Okay. Here, let's problem F. You find number of to k vertices such that the pairwise all the oh interesting. Exactly k vertices so that all the pairwise is that work. This is okay. 3, 4, 2, 1, 2, 1, 2. Consider all these. I see. Consider a node. Okay, this is easier to do than everything. I just need to somehow maintain dij is equal to number of vertices that I sorry. Oh, pairwise distances rather than so each so there must be a central vertex and k chains leaving out of it. And each of these chains should have some okay. Yeah. Nt sin nt while t minus c out solve and solve and nkc and n. Wait, why is this so small? Oh, okay. So I start a DFS at each vertex. So I route the tree at some node. This the yeah, I should do it. Cons resize n constant n is 100 plus the or DFS NTU and parent. Yeah, so basically in this problem there will be a central vertex to which everything is connected to. So I run a DF DNN number of vertices in the subtree of I which are at distance j from root. And also say pool array. Root it. DFS u minus 1 and depth 0 for each DFS EU depth plus 1 if we to be continued. I don't need this actually. This global instead. DUG just clear this array plus depth. Good. For 8VG and fix the depth. What's D? D is of the pool, that should make a difference. DVG A K NCK sets D is equal to 1 pages and okay, K is less than or equal to 2, it's fine. So here I have pick some key elements from here. Either I pick summation S subset of n is equal to K to product I in S D I. So either if I is in S, this is the same as S is equal to K minus 1 and product I in S D J plus summation S subset I Okay, product JNSDJ. Exactly, key elements, right? Big GNI. SDP thing should NTPN. I don't need to clear everything. I need to clear this children. TPI. Okay. S plus 1. DP00 is 1. Fix the depth. G minus 1. TPI 0 is equal to G. dv t plus I j. Yeah, this should be fine. Sure to take everything. Equal to d. Mm. Right. Let's consider 1, 2, 2, 3, 2, 4. Yes, the transition is fine. J is less than equal to I. What else it's missing? Do I calculate everything? Just D V J. 1, 2, 2. Cool. That looks fine. Root at 1. Then if you root at 2, there are 3 vertices left. 1. Cool. If you root at 3, 1, 1, 2, 0. It should be the same thing as 1, but yeah, okay, this is fine. This. Oh, I guess this m is equal to 2. Does it work for m is equal to 2? Oh, for m is equal to, you can Let's consider all the cases for m is equal to 2. Something weird for that case. Case to return it. Right. Ancestors are allowed. Yep. This only works for m greater. CS met. Nice. Okay.
What was your DP for this problem?
Yeah, so this was okay, so this was a bit involved. So first let's consider the case for k is equal to 2 separately. We'll take that later. So if you look at the tree, if you look at any set, you notice that any there will be a central vertex which is at the same distance from every vertex from this set. So
Yeah,
and all of these should, and any pairwise LCA should be the set central vertex.
yeah.
And after that you'll,
So what's your state
yeah, so
like exactly?
so I initially found all the vertices which are at, say, given. So for each child of this, so I fixed this for central vertex. Then for each child of this vertex I
Okay.
found all the nodes at a given depth. And
Huh.
then, so now then with this depth loop I just fix this depth. And then after that you have
Hmm.
to choose like k of these, say k of these children, and multiply all of this, k, choose k children, multiply all these counts you have of children at a given depth, and you have to say sum over all such k combination. So I
Yeah,
made a dp
that's
ij
pretty
for
much.
number of ways to choose j vertices, from the first I elements.
Oh, I see.
Yeah.
Actually, you can make like a simpler DP, like a DP depth and distance. So like what you do is ki, I mean it's probably the same thing that I did the same thing I guess. So what you do is you root the tree at some point, which is your central vertex,
Yeah.
and then you count the number of vertices at each depth, and then for each child of the root you do a you do a DFS, and for every you update the DP using a single pass from the highest distance to the lowest distance, and उसके बाद you just like compute
Achha,
for
okay,
every
okay.
depth the so
Yeah, I
that's the
got
same
it.
thing.
Yeah, yeah, it's the same thing. I just
Yeah.
did the DFS
हाँ
first and then updated the DP.
हाँ
Yeah.
and how did you do D2? Like D2 was kind of
Yeah,
like
D2 I
hard to
haven't.
implement for the
I haven't done D2 yet. Like I did D1.
oh
I like skipped D2 for now. I'll do E now.
oh I see.
Yeah. For
Oh
E,
wait, you haven't solved all the
yeah,
problems. Okay,
yeah, I haven't
never mind.
done E and D2.
Never mind. So,
Yeah, no, it's fine.
okay.
Mm-hmm. 42. This is the nicest thing. I'll just do E first. Right, this is pretty. delete this actually. Hmm. Good one for J to N J 0 minus. Mm-hmm. Yes. Okay. STP. Fine. And the do I need to have the I don't need I don't need to handle zeros. For I print and oh, AG plus A 10 N1 2 3 1 5. Yeah. Hmm. Which here? Mm, mm, mm. Oh, right. 1 0. Mm, 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 mm. Yeah, it's fine now. What's the edge case? Okay, finally this one. Right first. E E2 D2. In this case, answer does not exist. Bool flipped is equal to 0. Flipped is equal to 1. Cool. Just flip it at the end.
You should actually avoid downcasting.
What do you mean?
Like bool x is equal to 0 is kind of like really bad practice. So
Oh,
just
alright.
keep in mind.
So like false. Alright, good. A bit. To see. Or then G. Ah, right. I had this set up earlier. GNM. Counter. Counter is equal to 0. Base case, right. GI and new increment counter by 2 will decrease this by k g I j. And plus 1 is less than n g I j. Ah, should be okay. How to convert this? 0 0. Let me just check this. In out. Ah, this does not work. Punch is n plus punch. Right. 0 1 1 2 2. Okay. Hmm. This should be fine. Sometimes different. Then this is wrong. This 0. No. 0. Mm. G plus 1 is less than mgi. Provide equate to same thing, the same value or right. Now I need to convert this. Just four colors are okay. Yep, four are enough. Here. A, B, I. Let's flip the parrot. Okay. Out S I works. Ah, great. 0, 1, 0, 0. Perfectly fine, right? Yup. Counter k and 1 or it would say what? See particularly soft. Some
Wait, what exactly is the issue here?
Not sure. So like I just split it along the blocks, 2 by 2 blocks along diagonals, and I initially just gave each domino a distinct number, and
Huh?
then for the first diagonal I only use AB, for the second diagonal I only use CD, and so on, and decide which to use based on the parity of the domino number.
That makes sense. Yeah.
So I guess, is there something wrong with the construction itself? I
Wait,
don't.
there's no bug, right? Like this is correct now. Like three horizontal, and you have like A, B, B, C, C.
Looks okay. Yeah, this is fine. Three
So
horizontal A,
did you
B,
get a
B, C.
wrong? Did you get a wrong answer or something?
Yeah, wrong answer. Mm,
Acha, on test कौन सा?
Test 4.
Oh. Actually, like one thing, I mean, like should I मतलब help or something या फिर like
Nice,
थोड़ा दिमाग में
fine.
but yeah हाँ मतलब just so that like it becomes more like easier. So your construction works. I think your construction should work for like even n and m, right?
Yeah, it works. Yep, yep.
So
For all.
yeah, so you can. Did you see what you do in the last row? Or sorry, in the last row or the last column, whichever you do in the if.
Yeah, so I
तो
just.
इसमें
I don't think that causes an issue because it's only a choice between A and C that would make a difference. And I look at a 3 by 3, 3 by 2 block.
hmm,
Mm, 1, 2, 3, 0. Okay, 1, 2, 4, 0. 1, 2, 3, 1. Okay, 1, 2, 3, 2. G. A, B, C, D.
wait, why do you increment the counters just once? Like, can you try something like 4 3 2? That
Uh,
might make sense, I guess.
Nice. So I increment the count. Hmm. No, this is fine. So
4 4 3 2 में दिक्कत हो सकती है, I think. Like if you look at because 2 3 2 has just two columns, right? So I guess
4,
you
3, 2.
increment actually not 4 3 2, 8 3 2 or something. You should try that. So
1, 8, 3, 2. Even that works out fine. 1, 3, 8, 2.
something big, I guess. Oh, okay, yeah. 3 8 2
No,
and
no,
8
no,
3 2
no,
are
no, no,
different.
no. Yeah, so
Wait, what?
no, this is fine.
अच्छा
This is
ओके
fine.
हाँ
This is
ठीक है
fine.
that makes
Parity of
sense.
K changes.
हाँ this is fine, yeah. हाँ हाँ हाँ.
Okay, this. Oh, right. This is too much, too small. I need like 7. Huh?
7.
20, 7 should work. 1, 3, 8, 30. Oh, right. 7, 6. Yeah, 6 should work. The size issue. Oh, right. This.
Yeah, that's the issue that I was talking about.
This done?
So actually what I did was like a bit थोड़ा सा
Yeah.
different. So wait, what? Okay. So like मैंने तो ये किया था कि like I just solve मतलब जो मेरा एक function था that was just returning a vector of strings, and that was just for even by even, and if I have even by odd then like I do a normal transpose and वो वाला हटा के last row हटा के I solve for the everything, and then last row को I construct using a completely different set of things. I mean like XYZ or something.
Ah, yeah, okay.
So हाँ.
It's not the assigning. Yeah, so my first construction has an bug there. One, 3, 8, 6. Okay, this is the issue. I plus 1, 3, 8, 6, 0, 2, 1. Yeah, 2, 3. Yes. Should this be? Yeah, okay. Order. Flipping the order in which I solve. Yeah, now it's fine. I had to fill the last row later.
Very nice.
It was okay, fine. Oof.
Yeah.
I,
So
this,
discuss करने क्या?
I mean, I'm up for it.
हाँ.
There's
So
only 2 people here now.
so you
Yep,
कोई
yep.
नहीं. हाँ. So यहाँ पे पिंग कर दो like I guess वहाँ पे कि हो गया, so we are discussing the solutions. So
Uh,
actually यहाँ पे नहीं, दूसरा
all right.
दूसरा चैनल था
This
right?
right.
हाँ. Yeah.
The see join the voice channel.
So you can actually like look at my solutions as well. मतलब मेरे I think काफ़ी economical solutions थे मेरे. Like if you want to.
Yeah, sure. What's your right? Can
Yeah.
I
नहीं
can't
तो
I can't view
उसी
solutions
channel
right
पे.
now. 3 minutes.
Okay.
Yeah.
Like you can probably log out, right? Maybe
Yeah,
उससे
yeah, I
दिख
can log
जाएगा I
out.
guess. हाँ. Actually 2 minute ही थे तो it's okay. हाँ. Anyways. Uh, problems. अच्छा. Standings में I think I'm 20th or something. So you can have a look वहाँ पे.
20.
Unofficial.
Right, this.
Yeah. So
Right, so
problem A का solution वही था क्या?
I problem is I just tried n by 3 and plus or minus. I didn't take I didn't
Oh,
take cases. I just
okay.
tried everything
Actually,
in
like
the
there's a very
boundary.
simple solution. Acha. Like actually, just to prove that it's possible. So if you have n is equal to 3k, then 3 then k. I mean k and 2k works.
Yeah.
Otherwise, you have like there's a 2 extra. So what you do is you add it to add 1 to the second one to get a difference of 1. Otherwise, you add it to the first one to get a
Okay,
difference of
okay. So
1
based on
again.
parity. Yeah, so I
So
just took it
yeah.
like answer will be approximately n by 3. So I just tried out stuff in the
Makes
region.
sense. Yeah, makes sense.
For
So
B,
for B,
you just
what
greedily
was
pair
B?
up stuff.
Uh,
You have to color them differently.
अच्छा, color them differently. Like
You
I
were
was
given two
actually
color.
really weirdly stuck. I was really weirdly stuck because I thought that my solution actually doesn't work. So I tried to get a different color for the first row, like 112 उनका examples में था. So I tried to get 112 as मतलब बहुत ज़्यादा time, but I wasn't able to get it. So I just like rewrote the whole solution three to four times and then just submitted it. So
Yeah, I also
yeah,
made a
it was
mistake in this one at
yeah.
first. यहाँ पे did I do?
अच्छा.
Yeah, so I was trying to found the frequency and just give it to one side if I can. Right, so
Okay.
if
So
FC is non-zero, I just assign it to one color, and If
Yeah.
FC is still non-zero, then I assign it to the second color, which gives the wrong answer.
Okay.
So
Okay.
yeah, so
I,
now I
I
just
think you
found
should
on
have
base
actually looked
parity.
at the second, like the second problem first, like the B2 problem. I mean, B2 is like a much, मतलब B2 करने से
Yeah, wait.
you
B2
you
is
get a good idea of B1. So
actually
B2,
once
like I
I
looked at
do
B2 first.
once I did B1 of this, B2 was pretty simple to translate. So
Uh,
here I
yeah, it goes either ways, yeah.
yeah. So if FC is,
So
there's more than two elements, I can just provide them to both of the colors. And
yeah,
if there's
yeah,
only one, I just give it to one side. And I can do the same thing, but with
yeah,
k different things.
yeah, yeah, exactly. So you have a map, yeah. That was my first approach. So I thought कि कुछ bug होगा, but it's pretty much the same thing.
So what do you
So
do?
yeah, it's nice. Hmm. Uh, so what I did was कि like I have a map for count. So
Mhm.
उसमें क्या करता हूँ, like for every element I just like take the element and उसका count increase कर देता हूँ. And if the count is like less than equal to k, then I add it to like I mean, actually this is a ugly hack for finding the index of the element. Like ampersand x gives the address of x, and ampersand star a dot begin gives the address of the first element. So this gives um, the index. So you put the, yeah, you push back the index. So what
Okay,
you do
okay,
is
okay, yeah,
essentially
fine.
for every element you take the first k indices, and then you sort these indices by like the elements, and uske baad you just like actually this is one, but you should see the B2 solution because one will
Also,
be कि
wait,
हाँ I'm doing it this
I
way.
guess I'll allow non-mods to speak as well now, right?
Oh wait ऐसा नहीं हो गया.
No, 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 I had specifically set it so that non-mods couldn't speak during the VC. I think now
Oh,
they can.
save.
Yeah,
Oh,
now they
sorry.
can.
Oh, yeah. Any doubts like किसी को है तो बता दो मतलब, so that we can have a look. ठीक है, मतलब
Yeah.
सिंपल सी थी, लाइक यू टेक द फर्स्ट के इन occurrences, and then उन सबको चंक्स में ब्रेक करके एंड you directly do that basically. I mean, this is like this is B1, right?
Yep.
So in this problem मेरा answer of the that thing is like uh, like whether I'm taking that or not. So
Yeah.
so yeah, that's my definition. And
And for
actually I could have just done candidate dot size divided by 2. So
right.
B2,
But
yeah.
it's easier to copy over the code,
Yeah,
I think, in this case, like this.
yeah. So this is pretty much the same thing.
Yeah, same thing. You just have
And
k elements now.
yeah, k elements now. Yeah, so उसमें भी like I solved that first and then submitted that.
And
So
C,
problem C was
yeah,
nice, interesting story, right? So
yeah,
उसमें
I liked it.
there's this go. हाँ, I liked it as well. मतलब उसमें actually my wrong answer was because that I did C not equal to E instead of C not equal to F, and that case was not handled by
Ah, right.
these
Okay,
cases.
okay, okay.
Yeah. So essentially, what I did was I found like the frequency of. So I take
Frequency of the
every word and
differences.
then see frequency. Yeah, exactly. And then
Yeah,
using that, yeah.
mine was same. So like you reduce the string to only a number, and then you can just sort it.
Yeah, exactly. So, मतलब, I don't really know exactly a good way to uh, phrase the solution, but
Ye-
I guess you
Okay,
could.
so okay, one I to phrase it, I'd say you fix the most occurring
Yeah,
character first.
most common character.
Yeah, you fix the most
Yeah,
common character,
and then हर उसमें, yeah,
and then
and then you look at the residue, right?
yep,
Like
yep. So
the frequency
basically,
of
all,
everything. हाँ ठीक है.
so all the characters which are not this most frequent character are effectively the same thing. So, and only the frequencies matter. So you can say write the frequency of this character and frequency of rest of the characters. And you want to choose some of these.
Exactly.
You need to choose some pairs as that the difference the sum of this difference is positive. The pairs
Hmm.
ka.
Yeah, yeah.
And so the best way would be to, just sort
So
sort by the difference.
yeah, and then greedily take the
Yep.
largest till you
Hmm.
get like a negative sum. I
Yep.
mean, till you have a non-negative sum.
Yep.
तब तक लेते रहो. So yeah, that's pretty much the same thing. Yeah, makes sense.
Which extension were you using, like for submitting from the terminal itself?
Uh, it's CF tool. Wait, I'll send the GitHub link.
It's a GitHub, right? हाँ.
Yep, CF tool
CF
was it?
code.
This. I'll send it.
हाँ.
But ये तो सिर्फ टर्मिनल में नहीं है, VS कोड में इंटीग्रेट कैसे है?
It's
हो
not
जाता
integrated in VS. This is just a terminal. This is just an integrated
है
terminal in
मतलब
VS.
अच्छा
वैसे मैं आई यूज़ लाइक मतलब मैं उसको इसको यूज़ नहीं करता बट लाइक काफ़ी फास्ट हो जाता है लाइक व्हाट आई डू इज़ यू गो टू द प्रॉब्लम एंड देन उसके साइड में यू हैव अ सबमिट बटन तो उस पर मैं कर देता हूँ सो यूजुअली दिक्कत तो नहीं रहती
This
सो
one is useful, say, when I have to uh,
हाँ हाँ
test test on samples, and there are multiple samples, so it helps to test.
हाँ हाँ
So, for
या दैट
example,
मेक्स
for
दैट
this
मेक्स
one,
सेंस
it's not helpful here because there are multiple possible answers, but when there's a lot of answers and there's
हाँ
only a
हाँ
unique answer, then it helps.
so like
हाँ
it
हाँ
copies
हाँ
the input data set and all that to
Yup. Yeah, there's a command called race,
या
with something like this. It downloads everything and then generates your template and all. And currently I'm on Windows. I usually use Ubuntu. I just bought a new laptop, so I haven't set everything up. So on Ubuntu, currently I'm using WSL, so that doesn't work. But on if I run it through CMD, open. It will also open the this problems page when the contest begins.
okay.
So it's useful.
लाइक
And
यू कैन रीड द डॉक्यूमेंटेशन वहाँ पे
Yep.
इट्स एक्चुअली अ प्रीटी गुड टूल लाइक काफ़ी सारे लोग यूज़
Mhm.
करते हैं उसको सो यू कैन ट्राई दैट
This.
एंड D1 में या so D1 में like my construction was like actually kind of very straightforward like if you look at it so if you look at my submission मतलब for D2
Wait,
so
where's my
उसमें
mouse
like
gone?
you'll understand how the proof works
Oh wait. Right. Yeah, I don't know. My mouse disappeared for some reason. Okay, cool. C
yeah never mind
D1.
uh, so
Right. Right. Your
so like
construction.
firstly like yeah wait your resolution is like really low I think
Right
कुछ हुआ है क्या
now, I mean, nothing different really. I just reopened it.
okay okay
Is it fine now?
so so yeah I think yeah it's better yeah it's better.
Okay.
So for every test case, like I have NMK and then yes and no are like my functions for printing like yes and no
Okay.
because like C out likhna is kind of hard. So and then so yeah basically a work function बाद में देखेंगे like if you just look like थोड़ा नीचे जाओगे तो if n uh, wait is your stream frequency correct or कोई दिक्कत है okay
Uh,
never mind so if n like if everything is divisible by 2 then you can just like take blocks of 2 cross 2 and
mhm.
using that you can just like fill in your like requisite and you should just check that k is divisible by 2 because you need that to happen if you are
Mhm.
matlab, like you can use a simple chessboard coloring right
Yep. Yep.
for
Yeah.
that yeah and so what you do is like you reduce the case of odd like then you have two cases that n is odd or m is odd so I just assume without loss of generality that n is odd
Odd.
so
Okay.
and so then m will be even
Mhm.
and in that if it's not then you can just like swap it and you can just put a flag
Yeah. Fine.
and now you just need that since n is odd then the last row will have some issues right so last uh, so last row के लिए you have m by 2 horizontal, so you must have at least m by 2. uh, I mean k should be at least m by 2, and उस वाली रो के अंदर से if you remove all the dominoes, then k minus m by 2 possible dominoes will be remaining, and
Yeah.
in that case you can always construct, and you can show that uh, k minus m by 2 होने ही पड़ेंगे. So what you do is you remove the last row, so that's why there's n minus 1,
Yep.
and then you take the last column, like take the everything to the last column, and instead of k, now you have k minus m by 2 dominoes to place. And if you do that, then you have like a, like for the last thing you just like add the dominoes, like z z y y z z, oh sorry, y y z z y y z z. So now if you look at the work function, this is just filling in everything in pairs, like in 2 by 2 squares.
Yeah.
So yeah, that's pretty simple. So yeah, that was basically my solution. So this also kind of proves why these conditions are important, right?
Yep. Yeah. So I thought of pairing this up like this, but I didn't implement it like that. So I just first, so I assumed a construction first exists. This works because of this conditions being true, the rest of the solution will work. Now I assign. Now I greatly start assigning with the columns, column by column. I assign the values column by column. So in the first column and I and I plus one row, I place domino. Then in the next, so I try to fill this up one by one for each column. And the first I fill the first two rows. If once I'm done, then I move down to
Did you get disconnected or something?
no, I didn't. I don't think so.
Oh, okay, never mind. Yeah.
Wait. Hmm. Right. So I first pick the first column. I play. Yeah. So in your solution, you assumed n is odd. I assumed n is even. So uh, now again, I just greedily put everything, all the horizontal things in the first two columns, and I greedily kept because this is even, right? The number of rows is even.
Yeah.
So I assigned everything in the first two columns. Then I moved on to next column and so on. Then as such, I eventually get rid of all the dominoes. And after that, I started assigning the. I after that I started assigning the vertical tiles, and it worked because the previous step was fine. So like my issue, uh, so I had wrong answer earlier. That was because I was assigning it row by row. Uh, so first I fixed the first row. I
Yeah.
filled everything in the first row. Filled everything horizontally in the first row, first two rows, then the second row, and so on.
Yes, basically you need to like fill the thing that has even stuff. So with the
Yeah.
vertical stuff, right?
Yeah.
Yeah.
And for E, yeah, pretty much are the same DP.
Yeah, it's the same DP. Like you look at how many, like if you take the first I elements and उसमें से only J survive. So what's the maximum possible like numbers that can survive? I think
Yep.
something.
Yep.
Wait. Yeah.
Yeah, that's it. I was initially thinking of doing some other stuff, but the DP was similar. So if you store AI minus I, then deleting an element is similar to. Sorry, you store I minus AI. Then deleting an element is same as decreasing all the prefix by one.
Prefix,
Sorry, a
yeah.
suffix by
So
one.
you
A
could use
suffix by.
segment tree or something.
Yeah, I was thinking of doing
Yeah,
something like
suffix, yeah.
that. Suffix by one.
So
So I thought that might lead to a
so
solution, but
Fenwick types कुछ हो जाएगा.
I know. I mean, I think this problem should be solvable faster than O n square, honestly.
Yeah, same.
Yeah, but
So like I'll
DP
just
was rather straightforward.
so yeah,
Yeah, so you were saying.
So E में तो like हाँ mostly तो I guess wait, DP is like pretty straightforward. Actually, F is like the problem that I like the most about like in this
Yeah,
contest.
same.
So
Usually
yeah, so uh, eh,
they have some nice
F में I'll
graph
I'll just explain the
or
solution.
trees problem at the end of a div 3.
Yeah, yeah. So F में the solution is something like कि if k is equal to 2, then obviously you don't मतलब you can
Every
take any
pair.
two elements, and otherwise like k is equal to 3 या larger में like you have this thing कि like if you have three separate like three pairwise equally distant vertices, then like ऐसा होगा कि if you there must exist a vertex which lies on all three paths,
Hmm.
and which is also like equally distant from every vertex, so you have a center, and you can do this for like 4 5 and like k vertices ka set, so you'll always have a center. So what you do is you fix the root at and using that root you find like all sets of vertices, and you can show that this root is unique for every such set. So so what you do is like if you look at my solution,
Yeah,
उसमें I do this thing called like wait क्या कर रहा था मैं DP depth and size का use कर रहा था. So what it does is something like this कि firstly I count the depths for every node. So like if you root the tree at that vertex, and then my dpij is like कि at depth I how many vertices do I have of distance j, and all of those are मतलब not I mean all of those are कि sorry not number of vertices जिनका distance j है, but like number of sets of like size I think wait
number of vertices that are at a given depth from your child.
हाँ 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 या सो सो दैट एक्चुअली मैंने डिस्टेंस क्यों लिख दिया मैंने मतलब फॉर सम रीज़न कुछ वियर्ड सा हो गया होगा आई गेस, बट हाँ. So yeah, that's pretty much the same thing. So using that DP, you get like for every separate child, like I mean basically for every subtree, you solve that separately, and then using by iterating over the subtrees, you just update the DP values, and eventually you just need to find DP of depth and k.
Yeah.
So that's basically the solution.
You can make it faster, right?
Yeah, this is n square k, right?
Yeah, yeah, n square k. I think you can. Yeah, so like you have to. You basically have to like find something like you have to compute something like sum over product over of ai for I in S over all subset S of n plus that is. You basically have to find something like this, right?
Yeah, it's a Newton sum, yeah.
So
Like
can't.
वो FFT करके
Yeah, yeah.
you can do that like n log square or
हाँ
something.
हाँ वो exactly वही. I
But
think you can make it faster.
wait, but how is this like wait, how where does exactly this come from?
This is basically what we did, right? So first you choose
Yeah.
k children. Uh, s-
Hmm.
so uh, for the current node there will be some children, so you choose k of them, and
Mm-hmm.
for those k children, this you have to say, this is basically count depth I
हाँ
for a
हाँ
given depth is something like this, and you also sum
yeah.
over all depths. But yeah, so I've just optimized this portion. So we did this using an ON KDP or something. Oh,
N log square n.
yeah, and log square n. Yeah, oh, wait. ON K logs ON log square n. Yep,
Wait,
exactly.
count depths, like the thing is that count depths is being used. Wait, let me see. I forgot. where exactly I'm doing this. Problems.
But the thing is, you found you have to compute the
Uh,
depths here, right?
yeah,
Hmm.
exactly. So depth compute करनी पड़ती है हमेशा. So that's an issue. So actually, what you can do is that you can always compute the depths and okay, so you compute the depths of that subtree. That's the issue ना कि you have to always compute the depths of the children of a subtree rather than
Hmm.
like
Yeah. Can't,
so
I don't
that's the
know.
yeah I don't think you can do fast.
I don't know. I think we might be able to because you can find these depths while rerouting or something. It's a bit complicated.
हाँ वो that can be yeah complicated हो जाएगा वो थोड़ा.
Uh,
I mean
by
you'll have
whatever.
like some कुछ में +1 कुछ में -1 and count will be थोड़ा
You'll
अजीब सा.
need to use some sort of subarray which allows you some structure which allows you to like shift the array.
हाँ हाँ.
Yeah, yeah, okay,
Wait,
okay.
shift the array.
So you basically had
हाँ
depths now. Uh, F
हाँ
depths con compares the count, and when you go left, this index decreases for some, and like index increases for some. Wait,
yeah हाँ हाँ.
yeah, yeah, okay.
हाँ so उसमें +-1 वो देखना पड़ेगा क्या
Uh,
क्या होता है exactly.
I think you can improve it over this, but okay,
Yeah,
fine.
you can probably do that हाँ but it's थोड़ा सा हाँ
Yeah.
iffy सा है थोड़ा.
Hmm. Yeah, so I
हाँ
guess.
that's nice हाँ.
Hmm.
I mean the contest wasn't bad like usual div 3s are like कि बहुत बहुत ज़्यादा speed run होता है but I guess it D2 kind of kept people at bay I guess.
Exactly. D2 wasn't. I didn't like D2.
Mm.
E
It,
and
it took me like 15 minutes to implement properly. So,
yeah,
and I
I
got
think
W1 test 1, I think.
like wait, if you look
Wait,
at
how did I get W1 test 1? Oh, yeah, I got W1 test 1 because I did not subtract 2 from the K. So it was really bad.
Acha, oh right, so you okay, fine. You just kept placing horizontal
So,
stuff.
everything just
I don't know, my
gets
mouse keep
horizontal.
disappearing. Okay. Wait, I think I made a so basically I did A B C D1 pretty fast, then I got stuck. Wait, let me so
Achha.
so yeah, so A B C D1 I took 40 minutes, then it took like 50, it took me a long time to do anything after that.
That makes sense, huh? But yeah, it's nice kind of.
Yeah. I
Wait,
think
how did Aryan solve F?
I guess he just skipped to F directly or something.
Yeah, that. Uh, Oof. Zat coder submissions. K is equal to 1, then. Oh wow. K is equal to 1.
Yeah, I also initially took care of the k is equal to 1 case, then I realized there's no k is equal to 1 case. K is equal to 1, you just return
There
n.
is actually no case. हाँ. So, उसका K is equal to 1 था. And, अच्छा.
Hmm.
Y combinator क्यों use करता है? Just use like what I did ना.
Yeah.
Like my kind of DFS is like much cleaner
I
than a
started
Y
using that
combinator.
now. I started using that now as well. This time I didn't use it
अच्छा. Y
because
combinator or this?
no, your one. So like if you look at some of my late
अच्छा.
newer
I mean Y
submission,
combinator is actually like pretty good.
so say I don't know, wait.
अच्छा.
So for example, if you
Sorry,
started
I
using
missed
this,
one.
no, 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 so like I started using this sort of
अच्छा. Don't use universal references. Like what I do is const auto rec is equal to ampersand or const auto ampersand self or ये सब. And sometimes to enable compiler optimizations, I also instead of using ampersand, I use like exactly those captures which are needed because क्या होता है कि sometimes you have to make like more references like internally lambdas are implemented using like a struct which stores references so
okay.
that struct should not have a lot of references huh? and auto ampersand ampersand self has like थोड़े से weird semantics. So I would suggest कि const auto ampersand self. I mean not don't try const auto ampersand ampersand self.
Yeah, const auto
That gives you an error.
Yeah, okay.
हाँ, yeah. अच्छा, and wait, how can you work without like specifying the return type? I mean,
It detects here. I mean, it works. It works. It works pretty often.
sometimes it works. Like when you return something from these, then you can't. I think तब तो नहीं होता.
No, it works. You have
Like
to.
if you return like
It doesn't work if I don't return
हाँ,
anything. If I don't return anything, it doesn't work. So, for example,
oh
if
अच्छा,
I
like
remove this portion, I'd have to specify void here. I actually had an error yesterday because of this.
अच्छा, हाँ हाँ वो like if you need to actually either specify a return or sometimes what you need to do is कि wait self right हाँ
Yeah.
तो you probably need to actually this is like a bit weird like usually ऐसे what can happen is कि when you call it like you can sometimes call it with like using something else like you have another copy of the same like a similar lambda then you can call like okay so you have rec1 and rec2 then you can call like rec2 rec1
Ah,
and some stuff
okay, okay. You just
and
pass
second
the
call
other
will be
function.
rec1 and हाँ and वो अपने आप हो जाता है
I
वो
mean, it's the same thing.
so
You can
that's
just
the reason
replace this rect to with any function, right? No,
yeah
wait.
which should have like the similar but
Yeah.
sometimes like it won't compile usually but उसमें दिक्कत थोड़ी सी ये हो जाती है कि I mean self should have like a matching like something that can take itself or something
Yeah, yeah.
basically
Okay. Hmm.
yeah
Well, it should have the same argument types, I guess.
yeah I mean that's why I usually
Hmm.
like whenever I use lambdas तो उसके लिए I always have a trailing return type so that I mean at least वो पता लग जाए कि दिक्कत कहाँ हो रही है
Huh.
so yeah it's a good practice I think हाँ
Okay.
so wait if r minus l equals 1 then assert false and return what
Oh yeah,
leave it
yeah. So basically, I was a bit unsure ki if it ever reaches the node, so I just tried ki if it ever reaches the leaf. It never reaches the
अच्छा
leaf. It terminates before ever reaching the leaf. It should. If it doesn't
हाँ
terminate, I'm doing something really wrong. But
अच्छा okay
yeah,
हाँ that makes
I was
sense
just testing out stuff.
हाँ wait so you was this on a like completely new thing or was it on a different thing because usually you give like 4 spaces right
I use tabs.
this has like 8
No, I use tabs. I use tabs.
oh tabs
And I think
okay
Codeforces uses 8 tabs. Yeah, 8 spaces for a tab.
yeah